Hello and hi, I am Ain from Faculty of Chemical Engineering, UiTM Pulau Pinang, Malaysia. Today I would like to present my products called CaMoxCuyO Perovskite, or also known as calcium molybdenum copper oxide perovskite. Okay. Do you aware about our current issues in environment? Almost 80% of world populations having a threats to the water scarcity due to the widespread of urbanization and industrialization. Okay, previous studies stated that more than 60% of worldwide use of dyes there for printing, for color of the cloth, which contain the azote bond that were not biodegradable in aerobic environments, has led to the major contributions in the dye effluents. Furthermore, in this study, optimization of the operational reaction condition is yet to be addressed by using this perovskite catalyst. Hence, our objective in this study is one, to synthesize the calcium molybdenum copper oxide as our perovskite catalyst, and second, we want to doing the optimization of operational reaction condition using these perovskites. Briefly, what is a perovskite model? What is a perovskite catalyst? Perovskite catalyst is a combination of the ABX3, which A is committed to the rare or earth metal, B is a transition metal, and X in the halide groups. For example, X in the halide groups as oxygen, nitrogen, and sulfur. Okay, we go to the methodology, how we want to produce or synthesize these perovskites. We have to mix all the solutions in ETTA, ammonium hydroxide, calcium nitrate, ammonium molybdate, copper nitrate, and also the citric acid. Mix all together the solution and heat by using hot stirring plate at 200 rpm, and then we will go through two stages of calcination process. For the first pre-calcination, we use the 400 degrees C in 8 hours, and the second calcination, we go to 800 degrees C in 4 hours, and it will produce calcium molybdenum copper oxide catalyst in a powder form in a grey color. And then we will go through the optimization using design expert. Why we use this optimization? Our team has been decided to carry out the optimization AO2 degradation is to improve the overall performance of any reaction or the catalytic performance. Over the past decade, the traditional one factor at a time, or we call also OFAT method, was extensively used in many studies to determine the optimal operational parameters condition. In one factor at a time method, or in the OFAT method, the experiment was carried out by varying a single variable while keeping other variables constant at a specific value. However, this approach failed to analyze the interactions between all parameters and require large number of experimental runs and times as well. Therefore, we use the RSM has been replaced as a conventional method to figure out the optimal process conditions due to the several advantages. Okay, for the research findings in this study, we see that the ANOVA for quadratic model shows that the significance of the relationship between the response variable and the independent variables. Yes, the response variable is the percentage of the dye removal, and the independent variables is here as A, B, C, and D. We can see that A is the catalyst dosage, B is the dye concentration, C is the pH of solution, and D is the H2O2 concentration. Okay, the ANOVA for regression model of the AO2 dye removal demonstrated that the model is statistically significant owing to the low probability value, which is here, p value, and as well as the f value, which are the Fisher variation reaction. Okay, interestingly, p-value of the all variable here shows that less than 0.05. Okay, for the all operational parameters, which is indicates that all these parameters are significant in the regression of empirical equation model. Okay, in addition, the ability of the quadratic polynomial model is expressed on the basis coefficients of determinations of the R-square, the adjusted R-square, and the predicted R-square. Okay, so we can see from the table that R-square shows that 0.9941 indicates the good estimations of the predicted response. Moreover, adjusted R-square and the predicted R-square shows that 0.9886 and 0.9791 respectively, which reveals reasonable agreement. Difference is just between 0.02 only, and also suggests that there are excellent correlations between the independent variables. Okay, among all the parameters, the catalyst, okay, we can see that among all the parameters, the catalyst dosage in this graph, the catalyst dosage shows the most significant variable due to the highest of the F value, followed by the dye concentration, H2O2 concentration, and also the pH of solution. Okay. The contour of the plots, contour plots display the relationship between initial dye concentration, pH solution, and H2O2 concentration towards the dye removal. It can be seen that the decolorization activity of acid orange 2 was increased up to 80%. Yeah, was increased up to 80% after 50 minutes at low initial dye concentration in the range of 20 to 25 milligram per liter. 20 to 25 milligram per liter. Catalyst dosage of 0.9 to 1 gram. Here, see 0.9 to 1 gram per liter. pH in the range of 5.5 to 6, and H2O2 concentrations of 0.8 to 1 gram per liter. Okay, at high catalyst dosage, the number of active catalyst sites will be increased, which are responsible for the decomposition of H2O2 into hydroxy radicals. Okay, in this study, the optimum conditions for the regression model were found to be at 5.42 pH solution, 0.988 gram per liter catalyst dosage, 20.8 milligram per liter initial dye concentration, which subsequently resulted in 94.97% of AO2 removal. Okay, this research study were copyrighted by in the IPO, and we have also collaborated with the KCN company, which is a solution provider for the wastewater treatment. This was also covered and secured by the National Grant, Ministry of Higher Education in Malaysia, and also in an international grant for KWEF Japan, and one of the papers have been published in IOP conference series Material Science and Engineering. Okay. The findings presents new insights in obtaining proper model to predict the resultant performance of oxidative pollutants degradation based on the direct global interactions of optimal reaction conditions. Okay, the advantage of the products, though it is also can be commercialized into different plant, which are wastewater treatment and water treatment plant, whereby at the moment we have collaborate with the company as we have stated before. Okay, that's all from my study. Thank you for listening my presentation.